5-4, Solving Compound Inequalities, Day 3. Our essential question is, how do you solve and graph an interval inequality? And our question, our new vocab word, is interval inequality. Remember that an interval inequality is an inequality that has three parts to it. So it's a compound inequality that's like been put together with the word and it ends up with three parts. So an inequality So for example, it might be like 1 is less than or equal to x is less than 5. So it has three parts to it. So I think about it as in like the middle. You're trying to get the variable isolated in the middle when you're solving an interval inequality. And solving and graphing intervals can be a lot quicker than other compound inequalities. So our first example says to solve, -2 is less than or equal to x minus 3, which is less than 4. So to solve this one, I'm going to just have a double train track. I'm trying to isolate the variable, so I need to get the x by itself. When I do that, I would add 3, and typically on an equation or a single inequality, you would say add 3 on each side. Well, you can think about this interval as having 3 pieces, so we are going to add 3 to all of those pieces, like this, and solve them at the same time. -2 plus 3 is 1, and then we would just have x in the middle, and 4 plus 3 is 7. So I can graph this. I just need to go from 1 to 7, and then looking at the symbols, remember that if I turned this around, this is what it would look like if I turned it around and separated it. So x is greater than or equal to 1 would be a closed circle going to the right, and x has to be less than 7, so it's going to hit the 7 and stop, because less than 7 would be an open circle to the left. So this is my interval. So I think of it as from 1 to 7, and it's inclusive on the 1 because of the line underneath the symbol. So it includes the 1 but doesn't include the 7. So my inequality solution is what we had gotten up above. 1 is less than or equal to x, which is less than 7. So it's an interval graph, which is a segment. Your endpoints could be open or closed, and then it's an interval inequality. Here's another one just like that to solve. Solve it the same way with the double split track. Working to isolate the variable, I would need to subtract 1 on all 3 of my pieces. 5 minus 1 is 4. 9 minus 1 is 8. And then I need to divide everything by 2 to get the x by itself on this one. So 2 is less than or equal to x, which is less than 4. So 2, 3, and 4 are the numbers that we need. I will have a closed circle on the 2 and an open circle on the 4. 2 is less than or equal to x, which is less than 4. Remember that the graph, if you want to make sense of that graph, remember that I took this one and it's the same as x is greater than or equal to 2 and x is less than 4. So that's just splitting it into 2 separate inequalities. It's easier to leave it intact as an interval and solve it as an interval instead of separating it into 2. Okay, so now we just need to write an inequality for the graph. So this one starts at -1 and it ends at 2. I put my variable in the middle, less than or equal to, because it's closed, and less than. So keeping the numbers in the order from smallest, like the smallest number on the number line, smallest number, largest number, you're always going to have less than symbols or less than or equal to symbols in your compound, in your interval inequality. This means the exact same thing. If I flipped it all around, this means the exact same thing. 2 is greater than x, which is greater than or equal to -1. I just prefer keeping the numbers in the same order as what you see on the number line and using the less than symbol sign. But either one of these would be acceptable. The next one starts with -3. It's got an open circle, so just less than, and then ends at 4. Or you could write it the other way with greater than symbols if you wanted to reverse the numbers. Now we're going to write an inequality and graph for some word problem kind of situations. The range of acceptable scores on a test in this class would be from 70 to 100%. So 70, 80, 90, 100. So 70 to 100, and that's inclusive because a 70 is okay and so is a 100. So here's the graph of acceptable scores on your tests in math class. So that means 70 is less than or equal to x, less than or equal to 100 would be the interval inequality to go with that graph for the acceptable scores. The next one, most snakes live where the temperatures are between 75 and 90 degrees inclusive. So 75, 80, 85, 90. So inclusive means that you're including the 75 and the 90, like this. So 75 is less than or equal to x, less than or equal to 90 would be the acceptable temperatures. So we have an inequality, an interval inequality, and an interval graph. Okay, the next one's a little bit trickier. The sum means addition, of 2 times a number and 5. 2 times a number and 5. So those are the two things that are being added together. So 2 times a number and 5 would mean 2x plus 5. The sum of 2 times a number and 5. So I add together 2 times the number and 5 is between 7 and 15. So between 7 and 15. I'm going to use less thans on this one because it doesn't say inclusive, so I'm not sure that they want me to include the 7 and the 15. So I'm just going to go with open circles here. So I would have to subtract 5 on all 3 parts. 7 minus 5 is 2, and 15 minus 5 is 10. Then I have to divide everything by 2. So 1 is less than x, which is less than 5. So now on my number line, I would need to go from 1 to 5. And on this one, I'm graphing open circles because I wasn't really sure with the word between. They wanted me to include the 1 and include the 5. So 1, so I've got my inequality. 1 is less than x, it's less than 5, and my graph. So interval inequality, interval graph. Okay, you should be able to write a summary now. Make sure that you are answering the essential question and using complete sentences.